Hello, welcome back to another day of Advent of Code. This day we are doing day 10, and we're using the jakt language, which I've been corrected is actually Swedish for hunt or hunting. So I guess I recall Andreas talking about yaks during the introduction, and this is all being run on SerenityOS as well. Anyway, we should just get into day 10. So what are we doing here? So I had a quick skim of this and I saw the example input was insanely massive, especially because we can't select it because of the font or something. We could select all, but we can't, would then have to cut out a bunch of extra text. So what I did was just get it from the host system, and we've got inputs day 10.example, which should be that example input there. I will also do a new day. What are we up to? 10 double digits, and that's already got what we need. And the example output we could probably do, and that is part 13140, and do that, and it'll be cool. I should work out how, so like if we go lsd 10.jakt, you'll see this kind of has an underline and that has an underline, and you can kind of hover over, and if you either click now or double click, I don't know, it lags too much so my brain doesn't work it out, it will open it up, but I am unsure. Don't we have that? Yeah, I'm kind of unsure how we can have an output that kind of recognizes that it is part of it. So you see the ls, we know that it's part, but just echoing it out doesn't. But if we use it on a command line, it's good. And the reason why is because this new day, that was kind of weird. Oh, I see. Yeah, that seems to not be quite what was meant to do. Anyway, we're not bug hunting. We are solving this thing, which looks like it's implementing a CPU type thing. So we did that simulation type thing, which was kind of cool. And now they're trying to tell me something, the owls, but I can't hear them because, yeah. But we had that communication system that we got kind of working, but right, lots of water in it, so it's not really working. Right, so it's just a CRT screen and a CPU, and the CPU goes at right, so we've got a clock, and that gives us the ticks for the CPU. I might make this slightly bigger, and I guess this can go slightly smaller as a consequence. And I might have a look and see utilities. So what do we have here? Development, what do we have here? Yeah, so I guess we've got Hack Studio or the text editor. Oh, use Hack Studio again. So that we will need to just open up the folder for it, and we'll do that, and day 10 is what we want. And we don't really use this part, so we can't go further than that. That's alright. Can we get rid of this maybe? Maybe if we can hide some things, hide action tabs. Don't know what that did. Yeah, I kind of want to not see these side tabs, but it looks like that's not a feature at the moment, but it could be maybe when I get around to it. Anyway, back to the CPU. So we've got some ticks. We've only got one register. Starts at 1. And I assume what does the cycle start at? Do we need to know? Right, so only got 2 instructions as well. We can add to the register, or we can do no up and adding text to. And I guess they've kind of bolded the after, so after 2 cycles. So after 1 cycle, I guess it hasn't changed at all. So the first, right, so this is just kind of walking through that, and now we're getting the signal strength. Right, so this just goes, and we have to check it on a bunch. Oh, that's like, so the 20th, and then every 40, so 20, then skip a bunch, 60, 100, 140. So that's our example input. And so we just work out at the 20th cycle, X has that. That seems reasonably straightforward. And then do it again for all these. And we're like timesing it. Where did it say that? Up here somewhere, signal strength. Right, so this cycle number multiplied by that number. And yeah, that looks good. So sample number, whatever X is times by, well, whatever the cycle number is times by X. And then add all of those up, and then that's our answer. Cool. So I think for this, good excuse to try and do some cool stuff with the jakt language. So I guess we can have like a CPU structure, and what does it have in it? It has a register X, so we need to do like, it can just have X, and that has negative numbers, so we'll just call it an I64. And we've also got a cycle, or like, I'll call it clock. And this can be a U64, because it will start at 0 and go all the way up. And did it have defaults? I can't recall. I think it didn't. Tests, so 10 and example. It might be able to have those defaults. That is potentially cool. So I guess when we start this whole thing, we want to create a new CPU. So it's going to be mutable. And it can just be a CPU like that, maybe. And we're also going to have mute. I'll just call it part 1, and it can start at 0, and print line part 1, and do that, and part 1, and we'll do some like looping and stuff. So I guess we won't print stuff out for now, but what we could do is part 1 plus equal CPU dot clock times CPU dot X. And we're not going to do that every time, but I think just for now we'll just do that, because we need something in the loop, otherwise it won't compile. It won't compile anyway. Yeah, so we need to have oh yeah, we can do that. Maybe if I just do that, it will be happy. U64. We'll see. Now it still doesn't like something. Yeah, I think it did like that though. And I guess this clock has been I64. And that could potentially be negative, yeah, so we want that all to be that. Right, so now that's compiling. And I'm just wondering whether I just set clock to be I64 so we don't have to do these explicit things. But I kind of want it to error out when it does go negative. Though I guess it... no, I think we'll do it like this. Right, so now it's compiling, so it's doing some stuff. So we need to be able to kind of implement some, I guess we need a function on our CPU to step or tick. Maybe we'll do that. And it will take this and it will do some things. And so some things take multiple cycles, I guess. So add v takes two things. So I guess we want to tick with a instruction to read. So we need to have that instruction. Yeah, I think we will do run instruction, and it'll take this, and it will also take a non and we can call it an instruction, and it will just do some things. Now I kind of want, which I don't know if it exists in Yark, but I'm gonna hope it does, because we don't want to do this part one at every step, I guess. We want to do it at very precise things, and because we could be in the middle of this add cycle, it kind of means that we might I kind of want to have almost an interrupt that when we get to the cycle number that we want to check and get some stuff for part one, I want it to I kind of want it to, what am I thinking? I want it to interrupt out and say, hey, I've reached a certain, you've kind of got a listener subscriber kind of model. I'm losing my words, but I think I kind of want to do that, and then I can pass a callback to it to say, hey, on this step, run this. And so I could do something like this. And what you kind of want to, there's maybe that's too complicated, but I have a feeling the CPU class will come up in the future. I think if yeah, I think I should work it out, and we can probably even look in source jakt and look at some samples. So what do we have in samples that we can do? I kind of want a like functions maybe, samples functions, so we can do like a lot of different things. Can we I can't no I kind of want to pass a it's an enum, not a struct. I want to call it as a reference. But like a reference to a function. Or like passing a function as a, which I guess could be like a lambda might be what I might look for. If I don't see it here, otherwise I could just try it. I'm not seeing what I want. Len, closures maybe. Yeah, so we can do stuff like this. But then, no, I think, I don't know, it'll be kind of cool, but I think I am just not familiar enough with the language just yet to do it. So I think because of that, we need to like potentially in the instruction. Yeah, so we'll make this instruction, and it can have a well, it's more like an enum, but it's like a structure. Yeah, I think enum is what we want, and we want this to be add x and nuke. And we could probably have a function pass instruction, and that can have it can have whatchamacallit. We will take in a non-s, which will be a string, and we will return an instruction. And that will kind of just return. And this can probably do like the fat arrow and match on s. And then in there we can have addx. No, I think I can't because addx kind of has a number. Value I64. Yeah, because it's like kind of if it started, so I think I do need to go if s dot start with or like and we'll split it on a space, and then we can match our args there, and if it's add x, we'll do some stuff. We can probably return instruction add x, the value is args 1.2 int bang. Yeah, I think that is what I want to do, and if it's a not, then we can have instruction not, which doesn't have anything. Otherwise, we can probably have import, and it might let us do this. Return that, maybe. We'll see if this likes it. It doesn't like something. It doesn't like a lot of things. Right, so we haven't closed our enum. Right, I see what has happened. That makes it a bit clearer. Right, and we need a throw on that. Throws, and I think I could do something like this and as instruction, and like, of course it's going to fail. Right, so that's I32, I guess. Yeah, I've seen that before. Right, that looks better. That looks better. Now we get a C++ thing. Is that because of the abort? The abort cannot do that. We could do something like this, and yield instruction no. Yeah, I kind of want it to like. I think I want it to complain if it's an invalid value, but right, so print invalid instruction, and give it the instruction, and this can be yes. And also dirty print warning, the falling back to instruct to no, and then we can yield that and do something like that maybe. That looks better. Yeah. Cool. And I'm like spending like a bit of time on this because in past advent of codes, these like implement a fucking CPU usually come up again and again. So I kind of want to make it so it's like done kind of well. And yeah, this run instruction, I kind of want it to return a U64, which will be how many times it needs to keep on running. And we can have like a match on inst. That's why I needed do something like that. Right, we can have a match on inst, and it can have if it is instruction add x value, then that can return 1. It needs like one more instruction to go. Nah, I think that's not what I want. We could get the instruction out to start with, I guess. Inst equals instruction parse, and we can give it the line. And yeah, I think I'll just call that path. And maybe we can print that out. Print line inst equal that and inst. Right, and we need to kind of think on how to handle the ticks. So I kind of wonder if we can, if that's just like a struct, will it still do it? No, it won't. But if I kind of have fields on the struct, like left to go, and that can be a U64, and maybe defaults to 0. Right, and then we have to just do it there and see if this goes. This looks kind of good, and it's not complaining about stuff. So the no-op didn't have like left to go kind of set. Maybe I'll actually call this ticks, and this can be like immutable. I wonder if we can do a non and mute. Looks like we can. And we did have, well, we're not actually running that yet. So yeah, I think this is now just going to be tick. And this tick will this dot clock plus plus, and we'll do a match on inst, and if it is a instruction add x of value, then we'll do to do check cycles. Otherwise, if it is a instruction no-op, then we'll do a different thing. So ticks is what we want. inst.ticks plus plus. Maybe we can do that at this point here. So we do a tick, and not we just like never care. Now we also kind of want to have a complete, and that can be a boolean, and it can default to false. And then this can have inst.complete equals true, something like that. That was running for a while. Right, so clock is right, so we need this to be not a non-mutable this. And we kind of just need to do that. And it thinks it's, maybe we can't have, yeah, I think we can't have, no, it thinks that, I think I'll have an enum of opcode, and this can have this stuff, and this will be, in fact, can we do something like that and that? No. That, and do we have like a find replace? No. It's kind of interesting. The text editor has some features that Hack Studio doesn't, and vice versa. Well, Hack Studio has a lot more features than text audio does. Opcode. So I just wanted to do like a kind of find replace on this opcode. And opcode, and we can just call it invalid instruction. Or we could do some, no, I think we can do something like this. Yeah, and then in instruction we'll have a function pass, have a mutable this, and a non-s which is a string, and it will return an instruction, and this instruction will actually be a structure, and it will have a opcode which will be an opcode. And so here we can this dot opcode equals opcode dot parse and s match opcode, and if we have none, so I think we can do something like this. And if we have none, we can go equal invalid instruction that, and pass it S and abort, I guess. And otherwise, we can probably just go this dot opcode equals code bang, and we know it is not none. So we could probably just do that here equals code bang, and here we can probably do something like add x value, and this would do this dot cycles. I'm going to call it cycles, and then we don't need the then we don't need the complete, and so add x will have cycles of 2, and no op will have this dot cycles equals 1, and then if it's complete, it just means cycles will be 0 at the end, and then we set the opcode to be whatever it is, and it should abort if not. So I might put this none down there and try to make it a bit more obvious. And at this point we can return instruction opcode can be code, and yeah, so we don't actually want that because we don't have this, but we can have a mute cycles equals, we can just have 0 to start with, and otherwise it will become cycles, and we can probably just call this opcode, and opcode there, and I wonder if we can do something like that. Yeah, it's been a while since I've tried to compile to this. Right, so we do need to have opcode can be opcode bang. Right, so that pass needs to right, so we also need throws. Here's throws. Right, here is where we are. Right, I keep on just making syntax errors. I'll have a read of some other stuff. That's fine. We're probably missing. That looks all good. I'll give it another. Right, so where did it see that? 1, we need to, no, we've fixed that. We have fixed that. Show me where, here, right, so apparently this order is U64, and we'll probably need to do something like this each time. We don't know ticks, that's cool. Right, so in tick we will go cycles and minus minus, I guess. And in here, if inst dot cycles, and I think I do just want this to be an I, even though I've kind of already done it in a few places, and we can probably have it as anonymous as well. That we just don't really do anything, so that kind of frees up a line. So if we've got to, so if I dot cycles, I kind of want to do something like this, which I do wonder if Yakt kind of supports this, and then we will do something like this. Oh my god. And then we don't need that. See how it likes that, right? So it just doesn't like some things. Like some things. Expected type is an enum thing. Stock ID, module ID type. Right. Not that window, this one. Yakt. day10.yakt. Maybe we need something like that. Gosh, what an error. Doesn't really tell much. Expected type is in that. In fact, we can just say cpu.x plus equal value. We never actually call that. so it like doesn't like this opcode maybe. Gosh. Oh, I like deleted the character accidentally. Oh, that like doesn't like some things. That would be this. Mutable this, yeah. Oh, value is not found. How did we do those enums? Samples enums. So you can have stuff like this where you've got something in it. So I would have thought that that value came through in here. I guess we don't have this. It's right there. That is where the value is, but it doesn't know it. Yeah. Yep. Yep. It looks like it should just be there. We don't need the instruction to be. No, we do need the instruction to be immutable. But yeah, that match should. It just should know what the value is because of that. We're like only matching on I. We want to match on I.opcode. Alright, and now it's like, no, that's the wrong type. So I guess we can just be a 32-bit system. Clock we don't care about. Yeah, and now, right, so we can't get that. I32. Yep. I32 will just make it a bit easier, and that unsigned 32. In fact, we could just make an unsigned 16 and then it should like never overflow. That didn't like it. Now that's the error I was having before. Expected type in is enum variant. So I wonder if we just have yeah, I kind of just want nothing in there and it not to crash the compiler. Yeah, we could probably just call it like yeah, we'll just string, and it can just have that string in it. No, it still doesn't like that. It's frustrating that that doesn't really give a clue as to where it is failing. So I think it's in the does this have a just comment everything? Like just comment all of that. We kind of use it like everywhere. What I might do is edit that file in Vim, just because I kind of want to have this kind of block mode is what I was trying to say. So instruction cycles, and like see if that compiles. Right, so we don't know opcode down here, so we can probably just do that sort of thing. Right, so now we've got it in a compilable state, so it definitely doesn't like these opcodes. So what I might do is just uncomment the definition and see if it likes that. It looks pretty good. So what we could do is now just go through and maybe say that we're allowed an opcode, we're allowed to parse it, and we'll return that, and that's compiling. And so now we're kind of just reducing the things that kind of rely on it. We can probably even uncomment this, and it still compiles. So we just want it to compile all the time. So that kind of shows me that this is really the only place where it's failing, and I wonder if it's because we have that none or because we don't have something like that. No, right, I kind of know the area it is, so we will close that go back to this editor. Yep, there, it worked it out. So I know that it is failing in like kind of this part here. So right, I wasn't expecting a crash in Hack Studio, but it's alright. We will open up Hack Studio again and make it just a touch wider, up to there and to there, and we'll open up day 10. And I think so we added that, I think. Nah. Oh, are we meant to have... Yeah, I think we're meant to have a jakt, some, and maybe in grep jakt files. And we kind of want this to be inside of the match, which this looks like it could be in a match, but it's like that optional sum. Maybe I want to just search that in the samples directory and kind of see how that does it. Simple match on an enum, then samples enum simple match. This one had a sum and a type, well, sum that. So we can have that sort of thing. And how do we do a match on objectively better? Right, so yeah, I think that doesn't really. And we've got like a, we don't have like a none option there. Try that. Right, so we don't have none there. So I think if we do something like this, that might leave it. We don't want the none there, and we just return an optional opcode. We do that, right? So it doesn't like it. Yeah, and I think we want to have that and match on code, and then and do think that could be good. Code's right there. So I kind of, yeah, I think I want to, if opcode is some code, then we do that. Otherwise, it is an invalid instruction. It's ironic that I'm trying to add in like error correction, but it like just won't be needed. But yeah, I thought that was allowed. If is then we have his value. Yep. So I'll do that. If opcode.hasValue has the value, and then we can just match on opcode bang. Otherwise we abort and we do that. Right. This looks good. That's taken a while to get to this point, but it's kind of a good stage that now we kind of have an instruction and we have how many cycles each thing is meant to do, and now in this tick, well, we've in fact even done the tick, so what we need to do is, now that we've got the instruction, we can go cpu.tick, and that will while, and this is going to be mutable. So while I dot cycles not equal to 0, we do a CPU tick on I. And if at this point, if CPU.clock equals it's like the 20th, 20, or CPU.clock and maybe a bracket around this, minus 20, so that would make that 40, and then mod 40 equal 0. I think that's what I want. So if these are the cases, then we will do this command, statement. And do that, but it might not like this because CPU.clock might be less than 0, so it'll like underflow. So it'll probably error out because of an underflow. That's just my hypothesis there. Yeah, so we had a crash and yeah, check subtraction underflow. Or so we want CPU.clock is greater than 20 and all of that stuff, and then we'll add to the part 1, and so we've kind of got a, right, so it's still crashed, greater than equal to 20, right, so we go for ever, right, so in this we can have if CPU.clock equals, we only care about the 2/20th. So if it equals 221, for example, we can CPU. Well, we can just break, and we'll break out of. Oh, I wonder if we can do like fancy breaks where we break out of multiple things. Get break in samples maybe. We have a guard. Now it looks like we just have one kind of break. So maybe we can just do it as well. Really, it should run out of instructions. So I am actually a bit confused why it did get to that point. So I think I need some instructions, some things, print line debugging statements. Right, so I is this, and our current CPU state equals this, and we can just do I in CPU, and it'll just print out all the debug that I will need. So it should hopefully print out some stuff before it crashes, but it might just not print out anything. Yeah, because it's getting an error return. So that was one thing I did. So here we kind of want to just cat the output file, I think, because it will be useful to kind of see that. Yeah, so we get, this is the output, and I think that's the example output. Yeah, that's like literally the example output, but it's still kind of going too far. In fact, this hasn't, it has not done my prints there, which that is interesting. Yeah, so here we can see this I instruction. So it's, for some reason, only does one instruction, and we're adding a big number to 914880. Yeah, so yeah, I think because it's not actually every 40th, they only went up to the 220th. So I think if 20, what are we, 60, 100, 140, 180, and 220, and if that contains CPU.clock, then do this thing, and maybe go back so I can see if it looks all good, and then we shouldn't continually add to that. I want that window. Right, so it doesn't like this. I guess we can just pretend it's an i64. Where we go here is bang i64, and if we do that, cool. So that's compiling, and might not crash, and it might give us the right answer, but it should also take a very long time. So it seems endless, like we're not actually ever halting. Yeah, so it's if we do this inside there, it seems to not even get past the first instruction. Which, yeah, endless loop territory there. So that's just endless looping. And here we can see our cycles hasn't gone down at all. So the CPU ticks, and yeah, we did not can we do like a less there? So cycles is just always 2. Yeah, so cycles is always 2, and like kill day 10, because it probably didn't kill it, and I don't really want a task running in the background that's just going nuts. So I am wondering why this is happening. I guess we don't actually need to call it mute. We don't need to call it a non. So if we save that and run this, it's compiling. Still seems like it might be in this input. I guess it's not actually running in the background, but yeah, so never updating that. That is a bit confusing. Bit confusing why it's not updating the cycles to go down 1. And instruction is a structure because we wanted it so we could just go down 1. So this is still compiling. How long have I done? I've done a bit. I think I might give up and have a think on it and come back to it. Jakt day 10.jakt. Because I don't know why the cycles is not going down, and the cycles should go down on every loop in here because it does this tick, but that is just not the case. Are we like... I can't tell if it has succeeded building or not because there's sometimes some bugs. I think it has. So if we build day 10, right, so it's just running through and it's going heaps of clocks. So yeah, I think I need to have a think on this and just kind of work out why the cycles is not going down every time, like I would expect. And yeah, so I'll leave it at that. Good kind of prep work, and I'm very hopeful that this CPU type class comes up later in the advent, so should be reusable, and part 2 will probably be reasonably straightforward, but who knows. But anyway, for now, I'll see you another time.